We have been trying to understand consumer theory, and consumer theory is made up of two parts: consumer preferences, and we have represented through these through the concept of indifference curves, or ICs in short. And the other part of consumer theory is the budget constraint, and we have studied this as well. And as an example, what we had been looking at is an example where this person spends entire income on two goods, and as an example, one of the goods is apples, the other one is oranges. Now, a quick recap of what we know about indifference curves, particularly their properties. The first one being indifference curves are downward sloping. An indifference curve further away from the origin implies higher level of satisfaction. And the third property we have looked at is two indifference curves cannot intersect. And the fourth property is diminishing marginal rate of substitution. And this simply means as you have more and more of one good, the less and less willing you become to give up the other good. And in a way, marginal rate of substitution between apples and oranges is simply the slope of an indifference curve. And since we have oranges on the vertical axis, apples on the horizontal axis, marginal rate of substitution is simply change in quantity of oranges divided by change in quantity of apples. Then we also studied a budget line in the two good case where you have apples and oranges, and the intercept on the y-axis where you have oranges is income divided by price of an orange, and intercept on the x-axis, on x-axis we have apples, so income divided by price of an apple is the intercept on the x-axis, and the slope of a budget line is minus price of an apple divided by price of an orange. So we know about the properties of indifference curves, and we have quickly gone over whatever we need to know about the budget line. And in the next diagram, we bring indifference curves and budget line together and define what is consumer equilibrium. This diagram shows consumer equilibrium. Here we have the indifference curve. We also have the budget line, and what we find here is this point is called consumer equilibrium, and this is the point of tangency. I'll just write this down. Point of tangency between the indifference curve and the budget line. And at the point of tangency, what we have is the slope of the budget line must equal the slope of the indifference curve, and that is what we'll have at the point of tangency. And we know what is the slope of a budget line. It is price of apple divided by price of orange. What is the slope of an indifference curve? We know it is marginal rate of substitution. So when these two are equal, we have consumer equilibrium, or this is the best point from consumer's perspective. And this means two things. Number one, through consumer equilibrium, since this is the best point, this is where the consumer is likely to be, we can figure out how many apples and oranges would this person buy. And how do we do it? We bring this consumer equilibrium point to the horizontal axis, and what we have determined is the quantity of apples would this person buy given his or her preferences and the budget constraint. This will also give us how many oranges would this person buy. Simply bring this consumer equilibrium point to the vertical axis, and you have determined how many oranges would this person buy. So remember, this consumer equilibrium is the best point from the perspective of the consumer, and since this is the best point, we know the consumer is going to buy the quantity of apples and oranges based on this equilibrium point. And how do we get this equilibrium point? It's based on consumers' preferences and the budget line. Now, I have called consumer equilibrium the best point from a consumer's perspective, and the reason for this is consumer equilibrium represents two things at the same time. One of the things it represents is the highest level of satisfaction that a person can get given the budget or the budget constraint. How can we show this? Suppose we have this budget line 1, which is a binding constraint, so this person cannot spend more than what is implied by BL1, and we have consumer equilibrium on indifference curve 1. Suppose you are given another indifference curve, let's call this IC2. Now we know IC2 implies higher level of satisfaction relative to IC1, but given the budget constraint, IC2 is simply unattainable. So let me write unattainable. Look at another indifference curve which is, say, below IC1. Let's call this IC3. Now given this person's budget, we know this person can be on IC3, but then the satisfaction implied by IC3 is lower than IC1, and hence this statement, that is, the consumer equilibrium represents the highest level of satisfaction a person can get given the budget constraint. The second thing implied by consumer equilibrium, or the second reason as to why consumer equilibrium is the best point, is because it represents the least amount of expenditure or income required to attain a given level of satisfaction. And we can show this really quickly. We have this budget line BL1. This is the indifference curve where the consumer wants to be. This is the level of satisfaction that the consumer wants to attain. Now suppose we have a budget line like this one, and we can call this budget line, say, BL2, and it is to the right of BL1. Now given BL2, this person can definitely be on indifference curve, but the problem here is budget line 2 implies higher level of income relative to BL1, or what this means is, though you can be on IC using BL2, but then it requires more money. So in a way, the amount of expenditure we incur using BL1 is lower than what we would incur if it was BL2. Now look at another one. Suppose we had a budget line which implied lower real income, and let's just call this BL3, which is below BL1. But then if you have your income which is constrained by BL3, you cannot attain this indifference curve or this level of satisfaction. So at BL2 you're spending more money to attain a given level of satisfaction, or you simply cannot attain this level of satisfaction. And so this way we can prove that BL1 represents the least amount of expenditure required to attain a given level of satisfaction. So we know what is the condition for equilibrium, and that is marginal rate of substitution between apples and oranges equals the price ratio, which is PA by PO. And we already know when this condition is met, the consumer is at his best point, And you know what best point means. Either this person is getting the maximum level of satisfaction given the budget constraint, or this person is spending the least amount of money to attain a given level of satisfaction. Now look at the following as an example. Suppose we have a situation where marginal rate of substitution between apples and oranges is not equal to the ratio of prices. Just as an example, suppose marginal rate of substitution is given to us as -10 and price of an apple, just as an example, is $2 per unit and price of an orange is say $5 per unit, just as an example. And what we want for the best point is equality between these two. And what you find here is what is PA by PO here? Price of apples divided by price of oranges, and that is 2 divided by 5, or this will equal 0.40. Or what you find here is in an absolute sense, marginal rate of substitution between apples and oranges is greater than the ratio of prices, which is given by price of an apple divided by price of an orange. Now what should this consumer do? We already know that for this person to be at the best point, these two need to be equal. Now what can this person do? Now as far as this theory goes, we believe this consumer is very small in relation to the market. For example, when I go to Walmart, I'm too small in relation to Walmart, so I cannot haggle or bargain or negotiate a price. Whatever price is given to me, I take it as given and try to do the best I can. A similar reasoning applies here. We know one of the solutions to hitting equilibrium is increase PA by PO, but we know prices cannot be changed by the small consumer. The only thing this person can do is change MRS. And how should this person change MRS? This person should go on decreasing MRS and will go on decreasing it till marginal rate of substitution equals 0.40. Now look at the following. We have apples on the horizontal axis and oranges on the vertical axis, and we know an indifference curve is convex to the origin, or in other words, as you go down an indifference curve, the absolute value of slope of indifference curve or marginal rate of substitution declines as we go down an indifference curve. So if we want marginal rate of substitution to fall, what we need to do is move in a downward direction like this. And what this entails is, if you were initially at this point, you probably need to move to this point. Or in other words, what you need to do in order to hit equilibrium is increase consumption of apples and reduce consumption of oranges. So increase consumption of apples and reduce consumption of oranges, and you'll go on making this substitution till you hit equilibrium, and that is the marginal rate of substitution equals the price ratio. So what we are asking the consumer to do is, prices cannot be changed by, say, a consumer who's very small in relation to the market, but what this person can do is adjust his consumption behavior in a manner that these two become equal, and that's when the consumer will maximize satisfaction.